change your slides here. Okay. Thank you, Fabrizio. Good afternoon, ladies and gentlemen. Sorry for not speaking in Chinese. I will do my speech in English. Well, I can do it in French, but I think it will not help. Okay, so English it is done. TE is a world leader in sensors. We are providing sensors all across the world for a wide range of application. It is for automotive industry, for commercial vehicles, but also for medical application, military, aerospace, and consumer goods. Regarding commercial vehicles, we have here some of the sensors we are providing for this market: fluid level, fluid property, pressure sensor, position sensor. But for today, I would like to focus on a specific product that is called the QLS, and this is, how do I point it? Oh, good. Exactly, thank you for that. So I would like to focus on this product, which is called the QLS. So maybe just a few words of background. QLS stands for Quality and Level Sensor. If we have a look on a typical after-treatment system, the typical system will use for the NOx conversion the SCR as a selective catalyst reducer, and this kind of system use a fluid which is called the DEF. I think it's not a surprise for you. A DEF for diesel exhaust fluid, which is a mix of urea and water. And the QLS is this product that is placed inside the tank. And as a matter of fact, this is what it looks like. A QLS is more than a sensor, it's a complete unit. It's a complete one-in-all system, or all-in-one system, that provide all information and all features that are needed by the OEM to perform the SCR catalyst the right way. So it combines a level function. On TE technology is based on float system. We will discuss about this later on. It provides the temperature of the DEF in the tank, and it also provides what we call the DEF quality. The DEF quality, it's two informations. The first one is what is the concentration of urea in the tank, and this is to adapt the dosing rate to prevent to overdose or to underdose the urea in the SCR catalyst. And it can also be used to detect any risk of dilution because someone has added water in the tank, for example. And this sensor will also provide an information indicating if the fluid in the tank is the right catalyst reagent, if it's real DEF or it's something else, for example, because the end user has tried to cheat with the system, for example, by adding only water in the tank, or if the end user has made a mistake simply by putting fuel in the tank. Some of the end users may not be very well educated about the SCR, and they may confuse with DEF and fuel, and so they may put fuel in the tank, and you can imagine that putting fuel in the exhaust gases may not be very good. So the purpose of this sensor is to protect the system against this kind of misfilling event. But in addition to this sensing capacity, this kind of product allows other features. The first one is obviously it's OBD control, so it has self-diagnostic capability. So in case anything goes wrong with the product, then the sensor will be able to detect it. But it also provides some mechanical function. The first one is it will help to sew and to heat the tank through, for example, this kind of coolant loop here. So during the winter time, you will be able to sew the tank in case it's completely frozen, or you will be able to heat the tank to prevent the tank to freeze. It's also enabled to remove and to take the DEF out of the tank and to filter it. We have a filter at the bottom of the unit. And as most of the system, as indicated here, for the DEF pump, they take an excess of DEF out of the tank, and they have to send back to the tank the DEF that is not sent to the SCR catalyst. You have this kind of return loop. You have also the return line mounted on the tank, on the sensor. And the last feature is the tank ventilation, to be sure that the pressure inside the tank and the pressure outside the tank is equal, and so to prevent under or over pressure of the tank. So this kind of product, the QLS, is an all-in-one sensor that is needed to control the operation of the DEF in your tank. We have, I will try not to get this, that's better. We as TU, we have a unmatched and unique expertise in this DEF quality level sensor thanks to two acquisitions. We have acquired Measurement Specialties in October 2014, and Measurement Specialties at that time was among the world top 3 manufacturers for this kind of product. And just before the acquisition, Measurement Specialties acquired a company called Vima, and Vima was founded in 1987, and it was at that time the world leader for this DEF quality and level sensor. So thanks to this merging process, TE has really unique and without any equivalent expertise in DEF quality and level sensor. Our product, we have various types of product. Our product use for the level measurement two alternative technology. You will see later on we have either the reed switches or the magnetoresistive technology. For the DEF concentration, we rely on the ultrasonic technology, which has been proven to be highly reliable. And for the mechanical structure, we have the various shape of mechanical structure to adapt the sensor to the shape and to the size of the tank. And you're welcome to visit us at our booth to see some example. And you can see here on the picture that, whoops, this product is different from this one. So we can adapt the shape of the final unit to the need of our customers. Regarding the level measurement, we have two alternative technology. Both of them are float-based, and we can have either reed switches technology, which is discrete and digital measurement with a standard resolution of 12 millimeter. We can have other resolution, but the standard one is 12 millimeter. Or we can have magnetoresistive or AMR, which is also a real-time but continuous measurement analysis. And here we have a standard accuracy of plus or minus 3 millimeters with this kind of technology. In addition, we have some OBD and self-diagnostic capability. The measurement of what we call the DEF quality. So the DEF quality is both the concentration and also the detection of misfilling. We rely on the ultrasonic. The way it works, you have a picture of our ultrasonic sensor. This sensor sends ultrasonic waves through the fluid. This wave is reflected by the mirror here, and it's sent back to the sensor where it's catch. And through algorithm, we're able to detect the first echo, then the second echo, the third echo, because it's the ultrasonic wave bounce back and forth, and we're able then to detect what we call the time of flight. So what is the time required by this wave to go from the source to the mirror and back to the source? And as we know the distance, then we can compute what we call the speed of sound in the fluid. As a matter of fact, fluid have a unique speed of sound across temperature, and so we can compute. You have here a few examples of speed of sound for temperature for different concentration. And as we know the fluid of sound, as we know the temperature, then we can report what is the concentration. And regarding errors of liquid, for example, if we have filled the tank with fuel, this is the curve for the fuel. You can see it has a completely different shape than the DEF, or different concentration of DEF, and so the sensor will be able to detect it's not the proper fluid, and will be able to raise an alarm that the OEM will use to create an inducement on the vehicle. We have started the development of this kind of sensors back in 2006. At that time, that was the Euro 4 or the Tier 3 regulation in Europe and in the US. At that time, that was only the real level. The first quality sensor was introduced in 2009, and so today we can say that we are the only supplier in the world that can communicate. We have 12 years of experience in SCR system for depth level and 9 years experience in depth quality and level sensor. Our current generation is called the EST V2.6, that's this one. It started in 2012, and today we have more than 1.2 million units in the field at the end user using this technology and this generation of sensor. And I'm pleased to introduce you that we have started the development of the next generation of sensor that is called the QLS3 with improved feature. And as a matter of fact, this part is the next generation of sensor. This is introducing the UST3. You can have a look at the booth that the next generation of product TE will introduce next year. We have a global manufacturing footprint. Our TE strategy is local for local, so we have both engineering and manufacturing location in America, in Europe, and we have also a fair presence in Asia to be able to support our customers local to local. And it can be generated when the pressure or the temperature change. Last but not least, DEF is a strange fluid that freezes at -11 degrees C, and when it freezes, you have some ice expansion. So you need to pay attention about the mechanical robustness of the unit, and so it may have an impact on the shape and the position of the unit in the tank, and also how you will solve the liquid in the tank when you want to recover. So how you will heat your tank and how it may affect the system. And last, DEF is highly aggressive fluid, so you need to pay attention about the chemical compatibility. For off-highway application, you may have also a lot of dust in the tank, and obviously you may have a lot of shocks and vibration. So the point here is that when you want to use this sensor in your application, you need to pay attention that the real-life application condition will be highly different from lab condition. And we have 12 years here of experience to support our customer and to help and collaborate with our customers about those challenges. Let's have an example with case study, and let's consider the bubbles. This is in the tank. It is a strange fluid. It has a property to retain and to capture air. And so this air will generate bubbles under various conditions. So a few examples here. It will have outgassing phenomenon. This is what you have here on this picture. So when the temperature increases, for example in summertime, you have the vehicle outside parked under the sun, and so the temperature of the DEF in the tank will raise, and then we'll have a lot of small bubbles that will cover all surface of the product, of the sensor and the tank. And we will have this kind of situation here. There's a lot of tiny bubbles everywhere. It can also occur when you heat the tank in winter condition. So the outside temperature is cold, but as you are heating the tank to prevent freezing, then you will generate this kind of bubbles. You can also have this kind of outgassing phenomenon when the pressure drops. A typical example of pressure drops is in case you refill the tank with a pressurized pump system. The DEF in the pump is pressurized, so when it will reach the tank, the pressure will suddenly drop down to 1 atmosphere. And it will happen exactly what's happened when you open a bottle of Coca-Cola. You will have immediately generation of tiny bubbles, and those bubbles will stick on all surfaces. What's next? Next is emulsion. Emulsion can be generated, for example, by the return line. As I explained, on typical system, the pump take from the tank a lot of DEF, send some of this DEF in the injection system of the SCR catalyst, but the remaining quantity is sent back to the tank through what we call the return line. And so, in the tank, you will have a drop, so a column of DEF coming back from the pump that will fall at the bottom of the tank. And in the pump, this depth is pressurized, so it's put under pressure. A typical pressure in the pump is 12 bar. When this depth reaches the tank, the pressure will go immediately from 12 bar to 1 bar. And so what's happened? Outgassing. And you have here an example with a crystal tank. You can see here that we have bubbles because of the column of water falling down to the tank, but maybe it's not that visible on the screen, but you have also kind of cloud. This is an emulsion. This is tiny bubbles covering all the surface and blinding the sensor. You may have also bubbles generated by the pump purging. When the engine is keyed off, the pump, instead of taking depth in the tank to send to the catalyst, it will go in reverse mode. It will take air from the exhaust pipe to purge the pump and will send this air back in the tank. The purpose for the pump here is to be empty so that in case the vehicle go to very cold condition, there will be no remaining depth in the pump that will freeze and that will break the pump. The problem here is that sometimes our customers, they are using an excessive time for this purging system. And so the pump will send a huge amount of air inside the tank through the suction filter. So this air, when the pump will go into purge mode, will go through the filter and will generate a huge amount of tiny bubbles that will completely create like a milky depth. The depth in the tank will be highly aerated. The last for bubbles or emulsion, it's probably what makes more obviousness for everyone, is when the vehicle moves. This is a picture taken in a tank when the vehicle is moving. As you can see, the depth on the right, this is what we call the slush, the depth is completely aerated. This is quite an extreme case. This is a picture taken from an excavator where the excavator was piling rocks all day long. And you can see here that the depth is so highly aerated that it's completely white. It looks like milk. So we always explain to our customer that using this sensor and integrating this sensor, they will have to pay attention to system integration, because bubbles and emulsion for this specific case will occur for sure. No way to escape. This is a real life application, whatever the supplier and whatever the technology for this product. So, why is that a problem? One of this product function is to measure the depth concentration and to detect that the depth is indeed the right product. This means that the sensing element of the sensor needs to be in contact with the fluid. If you have bubbles or if you have emulsion, then the sensor is no longer in contact with the fluid. The sensor is in contact with something else. It's in contact with a mix between. I need to stop shooting the microphone. So the sensing element will be in contact with a mix of depth and air. It's no longer depth, it's something else. So the presence of bubbles and emulsion will affect the reading. And if things are not properly done, this will create artifact in the reading, and this will eventually lead to generate inducement for our customers. And so a product which costs a few hundred RMB will lead your big machine to go to a full stop and will basically ruin the working day of the end user. So we need to pay attention about that. The TE sensor is able to detect when we have this kind of bubbles or emulsion, and so will broadcast a specific message which is compliant to the CAN protocol SAE-J 1939, indicating that the sensor is not able to compute the concentration, and so the real meaning is not capable of measuring. So we are protecting our customer by indicating we don't know the concentration because we cannot measure it because of bubbles. However, the frequency and the duration of this situation is variable and is linked to the application condition. And in worst case, if the vehicle is shaking all day long and you have this kind of emulsion all day long, then the sensor may be in a situation where it will communicate unable to provide the concentration for a very long and prolonged period of time. And so OEMs are basically blind. They don't know what is the concentration in the tank. And so they cannot make a diagnostic if the concentration is correct, if they need to adapt the dosing system, or even if the fluid that is in the tank is indeed DEF or something else. So this is a problem. As a side note, our philosophy in TE is that we never broadcast a pre-recorded concentration. So we always provide either the computed concentration or a message indicating that we don't know where we are, and so we provide a kind of error message. We don't try to sneak with the system and to provide, for example, the last computed concentration. We consider that this is a non-compliance regarding the regulation. We prefer to let the customer work on the complete OBD. So we have the diagnostic, and now we have the problem. What are the solutions? We have three items for the solution. The first one is we have the solution that TE can implement directly in the product. And these solutions are linked to specific design rules to mitigate the impact. For example, I explained about the risk of emulsion being sent back in the tank by the return line. One of the solutions we have implemented is by using this cap here. It looks like a filter. Actually, it's not a filter, even it's similar. And the purpose of this cap is when the DEF goes back to the tank, the bubbles are captured by this cap, and the liquid goes back in the tank. So with this solution, we are able to avoid any issue that may be generated by the pump. We have also some design rules about how the sensor, how the return line has to be oriented, and what is the shape. We have also some design rules about the position and the orientation about these quality units to mitigate the potential impact of bubbles. We have also some firmware feature. We have some advanced algorithm, and so we are able to compensate to a certain extent about the impact of these bubbles, if they are moderate, or to detect that we have too high level of bubbles, and so we report this error message. We can also have some data filtering to prevent spikes of concentration. And additional feature, I hope you don't mind if I don't provide all my confidentiality design rules. I prefer to keep it for TEs for now. We have also the second contribution is linked to the OEM. On the OEM side, they need to pay attention about the heating strategy. During the winter time, they need to pay attention, for example, that when the tank is melted, not to continue to heat the tank. The more heat we will provide to the tank, and the more risk of outgassing we will generate. It's also a recommendation for the OEMs to avoid the proximity of heat source, avoiding to expose the tank, for example, to direct sunlight, or to have the proximity of the engines or some exhaust system part. Because this will generate heat that will lead to generating bubbles in the tank. It's also working on this pump purging sequence to be sure that the purge sequence time is sufficient to empty the pump, but not long enough to generate a huge amount of air back in the tank that will create this kind of foam or emulsion back in the tank. Obviously, to state the obvious is to place the tank in a position where you will mitigate the amount of vibration of sloshing. Just to make a very extreme example, you can figure out that in an excavator, it's better position to have the tank mounted on the chassis than to have the tank mounted at the extremity of the boom, because this is the location where you have the most movement and frequency. And this is where we can provide support to our customers because we have 12 years of experience in this kind of application. The third item is the QLS supplier and the OEM needs to cooperate. We are not system owner. We are the sensor supplier. But we have some experience because we have worked with other customers and we have worked with other environments, and so we can cooperate our customers by providing recommendation on the field testing that needs to be done to generate these bubbles, by working with the customer to generate raw data acquisition, and so to understand exactly what's happened and when it's happened, and so that we can help our customers on defining the complete OBD strategy that can be aligned with the regulation. This is what we did. We did it for 12 years. We did it for off-road application, and some of them are pretty extreme, as you can figure out, as you can figure out on this beautiful picture. Oh, by the way, the driver needs to be courageous here. We did it on on-road application, but also on off-road trucks. And we did it for a wide variety of regulation in Europe, in Asia, in America, and now in China and in India as well. And thanks to analysis, this is where we can create the added value for our customer by providing the support for the system integration. At the conclusion, a few facts. TE is the #1 supplier supplying this product, the depth level and quality sensor. The key message here is system integration requires specific attention from the OEMs. The OEMs needs to do a real field validation acquisition for this kind of product. Do not rely only on lab tests. We have a unique expertise, so we can support our customers to run the proper system integration. We did it. We have an extended portfolio of depth, quality, and level sensor widely deployed across the world and for various range of application on-road, off-road, whatever the regulation. Thank you for your attention.